So to recap, when we looked at hypothesis testing about mu, the first thing we did was we hypothesized a particular value for mu. We hypothesized a value for mu in the population. So for example, this might be what is the status quo. That might be the mu sub naught. We call that mu sub naught for the null, zero, null hypothesis. So this is a hypothesized value that we take. Then we take a random sample of size n from that population, and then we ask the question, is it likely that the sample came from a population with this mean? Mu sub 0. And what we mean by likely is we don't want to reject this hypothesis. When in fact it's true, we don't want to reject it 95% of the time, say. Or we only want to run a risk of alpha of 0.05, for example. That gives us a 5% chance of making this mistake, rejecting this null hypothesis when we shouldn't. So first we decide on a statistic. Since we're talking about the population mean mu, the statistic that we might decide on is the sample mean x bar, because it's directly related. Its distribution, as we saw from the central limit theorem, is directly related to the population mean mu. Then determine which values of x bar are consonant with the hypothesis of the mean that we have stipulated in our null hypothesis of the population mean. So a predictive interval would be one way of doing that. Or another way of stating that is look at the standardized variable, which is the mean, sample mean, minus the hypothesized population mean, divided by the appropriate standard deviation, which in this case would be the standard error. So it's the population sigma divided by the square root of n. Then decide whether this difference, the difference between the sample mean and the hypothesized mean, is too large or not. Now, that's a little tricky to decide whether it's too large or not. First, we have to standardize so that now we put this on a standard scale. So 95% of the time we expect this between minus 1.96 and 1.96. There's a wrinkle in all of this when we start talking about deviations in either direction, or maybe we're only interested in deviations in a single direction. So what we call this is, we call this the issue of one-sided or two-sided hypotheses. The two-sided hypothesis is the situation where we are interested in mu equal to mu naught, and the alternative is in either direction, mu not equal to a mu naught. Either mu is bigger than mu naught or mu is less than mu naught. So that's the alternative hypothesis. The alternative and the null, these two, the union of these two, should cover the whole terrain. So if take the null hypothesis, mu equals mu naught, join it up with the alternative, you've got that mu could be anything. Another way of viewing this is a one-sided hypothesis. So here we're interested in whether mu is bigger than or equal to mu naught. That's the null hypothesis. Versus the alternative that mu is less than mu naught. So in this case, we would look for deviations between x bar and mu in the negative direction. Because if x bar is equal to mu naught or bigger than mu naught, then we would be in the null hypothesis situation. Whereas if we're down there, then we're in the alternative domain. The other one-sided is just a mirror image of this, and that is that the null is that mu is less than or equal to mu naught, and the alternative is that it's bigger than mu naught. This you set up beforehand, before looking at the data. Which one of these is appropriate? This one, or this one, has to be decided before you look at the data for all of this theory to be applicable, for this to be correct. You can't, after the fact, look at this and say, oh, no, look, it's smaller, so let me just do the one-sided. No, that's not how this theory was worked out. It's based on you deciding beforehand that which one of these three situations you're in. And because there's chance for finagling here, you don't see these two very often. This is the situation you see more often than not. And once again, since this is completely equivalent to confidence intervals, the confidence intervals you would look for here are two-sided confidence intervals, whereas here you would have one-sided confidence intervals, and you usually see the two-sided confidence intervals.